My name is Dr. Chris. I hold a doctorate degree in mathematics. I'll be running the third part of the series I started, Introduction to Statistics. We did the part 1 and the part 2. Part 1 talks about the definition, the types of data, methods of collecting data, sources of collecting data, and also methods of presenting data. We also looked at the part 2. We discussed the challenges in data collection and how we can overcome the challenges. Today we'll be looking at, I will want to first of all plead with you to subscribe to my YouTube channel. Try and like my videos, subscribe, share the videos, the links on your social media handles, your WhatsApp status, your Facebook, and the rest of them, so that we can have more people viewing. When you subscribe, anytime I come online, you will be the first to be alerted. So please stay patiently with me while I run through today's class, which is part 3 of Introduction to Statistics. You will be knowing at the end of this class, you will be knowing the types of statistics that we have, the nature of data that we have, and what the difference between population and sample and the various measurement scales is very, very important. So today we are looking at Introduction to Statistics, part 3. Before I go into the main things we have today, let me first of all give another important definition of statistics. Statistics can also be defined as a body of tools or techniques applied on data in order to make quality planning, decision making, and forecasting. This is a major tool, a major definition of statistics. It's a body of tools, it's a body of methods, it's a body of techniques applied on data in order to make, number 1, quality planning, number 2, quality decision making, and number 3, quality forecasting. Now we'll be looking at types of statistics. We have 2 major types of statistics. Number 1 is the descriptive statistics. The job of the descriptive statistics is to describe data and summarize them. So when data are described and summarized in a particular way, you can use that is what we mean by descriptive statistics. So for instance, we can use measures of central tendency like the mean, the mode, the median to describe data. We can use percentages, we can use graphs, the pie chart, the bar chart, the histogram. We can also use the measure of variability, the standard deviation, the variance. We can use the measure of position, the quartiles, the deciles, the percentiles. These are various ways we can describe data. And when data are described, it is very easy to interpret. So you describe the set of data from a sample or from the population. Then number 2 types of statistics is inferential statistics. Inferential statistics makes use of values that describe a set of data to test hypothesis. This one has to do with using properties from a sample to test hypothesis. So this has a lot to do with hypothesis testing. And of course, in statistics, we have two types of hypothesis. We have the null hypothesis. I'll quickly, briefly talk about the types of hypothesis. We have the null hypothesis HO and the alternative hypothesis HA. The null and alternative hypothesis, types of hypothesis. Number one, we have the null hypothesis. It's normally denoted as H subscript 0. And the second one is called the alternative hypothesis, and is also denoted as H subscript 1 or H subscript capital letter A. The null hypothesis is the hypothesis that is assumed to be correct. It's always saying there is no significant difference between or among the variables tested. But the alternative hypothesis is always contradicting the null hypothesis. If the null hypothesis says there is no significant difference between the variables, the alternative will say there is significant difference. At the end of the day, you carry out your test and you know which of them to decide, you decide on which of them to accept or reject. That's what we call decision rules. We'll go into that when we get to statistical inference. Hypothesis testing is a course of its own, is a topic of its own to be treated another day. So hypothesis is just a fact. A hypothesis is just a fact that is yet to be tested to be true or correct. It's a statement. It's just a statement that is yet to be proven. It's a statement that is a hypothesis is a statement that is yet to be proven to be true or correct. So now we'll continue by looking at what we call parametric and non-parametric statistics. It's very important we know what we mean by parametric stroke non-parametric statistics. Parametric statistics depends on the assumption of the distribution of the population where the sample was drawn. So it depends on the distribution of where the population was drawn. So an assumption must be known about the population distribution. If it is not known, then we cannot use parametric statistics to analyze such a data from that particular population. So we need to know the distribution must be known. And we have example of parametric statistics. We have the Z-test, which is known as the normal distribution test. We have the F-test, which is known as the analysis of variance test. And we also have the T-test, which is known as the student T-test. These are tests used in parametric statistics. Now, before you carry out parametric statistics, the parameters must be known, the properties must be known. And when they are known, they are tested using any of these. Though there are more parametric tests that can be used. Then this takes us to the next one, the non-parametric statistics. The non-parametric statistics do not need any assumption about the distribution of the population where the sample was taken. Non-parametric statistics, normally they deal with data that are nominal or data that are ordinal. We normally use them for categorical data, but for the parametric statistics, we use parametric statistics for data that are collected using interval scale and ratio scale. When we get there, you will know what interval and ratio scale, what they are. So this is what we mean by parametric or non-parametric. So whatever analysis you are doing, it can either be parametric or non-parametric. When the population distribution is known and the parameters are known, we make use of the parametric statistics. And when the distribution where the sample of the population where the sample is drawn is not known, there is no assumption about it, then we can make use of the non-parametric statistics. Now this takes me to what we call discrete. These are terminologies that you need to understand in statistics. Again, I want to plead with you, subscribe to my YouTube channel, like the videos there, and share to your various social media platforms. Help me to spread this video. By doing that, you are sharing knowledge. You are sharing knowledge, and as you do that, God blesses you. Now, I want to continue. Let us look at discrete and continuous variables. Continuous variables. Number one, discrete. Variables. Discrete variables are variables that represent count data. They have finite number of terms. They can be counted. Finite number of terms. Like e.g. the number of balls in a box, the number of clothes in a box of clothes, and so on and so forth. When the data can be counted, they are called discrete. Such a variable is called a discrete variable. They can be counted, they can be numbered. They can be counted and they can be numbered. Example, we have weight, we have height, and so example of object that can be counted: the number of balls in a box, the number of shoes in your wardrobe, a pair of shoes in your wardrobe, and so on and so forth. So now the other one is continuous variable. Continuous variable, they represent measurable amounts that can be measured, measurable amount within a time frame. I give an example: the height of a boy from his first year to his 20th year, for instance. The height is measured, a child is expected to be growing. The first year you measure the height, second year you measure, it keeps increasing, so it varies and it's continuous. So that variable there is continuous. Just like also the weight, the height, and so on and so forth. It keeps increasing with time, within a particular time frame. So that's what we mean by discrete. So for discrete, you can count the number of in the data set. For continuous, it's just within a time frame, it's just increasing, it's measurable within a particular time frame. Then now we are looking at what we call qualitative and quantitative data. Qualitative and quantitative data. Qualitative, so quantitative data. This part is very important. When you are collecting data for your research, your data can either be qualitative in nature or quantitative in nature. Let me explain each of them. Qualitative data. These are data that are given in categories. They are measured in categories. Categories. They are categorized data. They are categorized data. So they are categorized data. Now, when data are categorized, example, you have gender. Gender can either be male or female. Then we have genotype. Genotype can either be AS, AA, or SS. Then we have color. You can have blue, red, and so on and so forth. Blue, red, and so on and so forth. So qualitative data are data that can be categorized. Are you getting me now? Then the other type is the quantitative data. Quantitative data are data that are numeric. They are number that can be, you can measure them and they can be numbered. The number, you can measure them in numerical form, in values. So they are numeric. Unlike this one that can just be grouped or categorized. And one beautiful thing is that for parametric statistics, we mainly use quantitative data. While for non-parametric statistics, we mainly use categorical data. So you must understand the difference. So when you are doing research, your data can either be qualitative or quantitative. And when they are qualitative, we expect to use non-parametric statistics to do your analysis. And when they are quantitative, we expect you to use the parametric statistics to do your analysis. Now this will now lead us to scales or measurement scales or scales in measurement. Scales in measurement, or we call them scales of measurement. There are 4 scales. Number 1 is the nominal. The nominal scales only identifies or categorizes. It tells you whether it's a male or a female, it will identify it, the gender. Then the number 2 is called the ordinal. The ordinal will identify, and at the same time it will also order or rank the data. So it will rank the data in position. Then the third one is the interval. The interval will identify, it will rank, and it will also tell you the space in between data sets. This interval, they are numeric. These two are qualitative in nature. They are used for collecting qualitative data, the nominal and ordinal. While interval and the fourth one, which is ratio can identify, is the highest form of measurement, highest scale of measurement that you have. It can identify, it can rank, it can space, and it can even tell you the measurement in terms of kg, in terms of calories, and so on and so forth. That is what the ratio does. So these two are for quantitative data while these other two are for qualitative data. So when you have a better understanding of these categories, these two are for qualitative data, and the best way to analyze them is the parametric and non-parametric statistics. You use non-parametric for nominal and ordinal data for qualitative data. Then the interval and ratio, they give you numerical values, and they are mainly they are quantitative in nature, they are quantitative data, and you analyze them using mainly parametric statistics. Then, before I round up, I will go again to statistics and population. Population and samples in statistics. You can't talk about statistics and not talk about population. You can't talk about statistics and not talk about samples. A population is the entire group. The population is the entire group under study. It represents the phenomenon that is under study. When we talk about population statistics, we are not just talking about people. We are talking about something that you want to carry out study, but it can be living thing, it can be non-living thing. Then when the population is not easily reached, we cannot talk about sample. A sample is a true representative of a population. It's a segment, it's a part of a population, it's a fraction of a population. When samples are taken, you ensure that every part of the population is represented. You do it without bias. You don't favor a part of the population and neglect another part of the population. You make sure every part is well represented, and whatever analysis you do with the sample, it will be used to generalize for the entire population. So there are advantages of taking samples over population. Advantages. Number one, it saves time. Number two, it reduces cost. Number three, it also reduces fatigue. And number four, it gives more accurate, precise results. So these are key terminologies you need to know in statistics, and when you have them, you will do well in statistics. So nice again having you around. Please subscribe to my YouTube video, to my YouTube channel, like my videos, share it on your social media platforms, your WhatsApp, your Facebook, and the rest of them. And God will bless you as you do. In my next video, I'll be coming up with how to create the frequency distribution table. How to create a frequency distribution table. When data are collected and they are very large, how do you create a frequency distribution table? That is very, very important in statistics. There are rules to be followed. That is what I'll be doing in my next video. So please subscribe so that when I upload it, you will be given an alert to watch the video. God bless you. Thank you again for watching. Have a great day.